Hello there guys, and welcome back to another epic inexorable maths video. In this video we're doing more integration by parts, and I've got two different examples for you. The first example is the same question as from the last video. The link is in the description to the last video, definitely check that out. We're going to do this, we're obviously using integration by parts, and I've added a little bit of spice to the question as well, because we're not only integrating x times the natural log of x, but we're actually going to put some limits in so we can see how do we apply the limits when we do integration by parts. So the lower limit is e, that's the number e, 2.7, etc. And the upper limit is the number 5. Let's just dive straight in. So with integration by parts, one function needs to be u and one function needs to be dv dx. So we're going to label u the natural log of x, and we're going to label dv dx x. Okay, if you're not sure why it's that way around, check out the last video where I explained the order of priority for what you should let u be equal to. Long story short, we're letting u be the natural log of x because logarithms have a higher priority for what we should label u than x, and x is an algebraic function. So logarithms come above algebraic functions when it comes to deciding what u should be. Remember the acronym LATE. Logarithms, algebraic, trigonometric, exponential. The higher up that is, the more likely you want it to be u. Logarithm, there we are, it's u. Okay, we then are going to differentiate u. Now the derivative of the natural log of x is 1 over x. And we're going to integrate dv dx. So just v, the integral of x is a half x squared. Okay, just like that. Cool. Then what we're going to do, guys, is we are going to use the formula. So this integral, and by the way, guys, I'm going to call this integral I, just so I can refer back to it a little bit easier. So the integral I is equal to, and we're going to plug everything in. So this integral is u times v, so u is ln x and v is a half x squared. So we have a half x squared times the natural log of x. And we're going to take away the integral of v times du dx. V is a half x squared and du dx is 1 over x. So we're going to take away the integral. Half x squared times 1 over x, we're basically just taking this and dividing it by x. So it's a half x in the integral. So minus a half x dx. Okay. Now, how do you apply the limits? This is how you do it. What you're going to do is you're going to put your normal square brackets around the u times v part, and you're going to put your limits in here. So this is ready to just plug the limits directly in. This integral needs to keep the limits there. We need to integrate this and then plug it in. So you're going to kind of have two separate sets of these square brackets, okay? That's kind of how you deal with the limits. So let's plug the limits into this one right now. Why not? So a half times 5 squared is 25 over 2. That's being times by the natural log of 5. So we have 25 over 2 times the natural log of 5. And we're going to take away the same thing but plugging in e. So a half e squared times the natural log of e. Okay? So half e squared times the natural log of e. And you might know the natural log of e is the number 1, but we'll come back to that later, okay? That's what we have so far. We're then going to subtract this integral here. The integral is a half x dx. So what is that going to integrate to? That's going to become a quarter x squared. Because if you differentiate this, the 2 will come down, gives you 2 over 4, which is a half, and then you take 1 off the power, so you have a half x, which is what was here. So that's how we know that that's right. And then that's being evaluated again with 5 and e. So maybe I will kind of come over here slightly, guys. So sorry for kind of going down and then back up again. Let's rewrite what we have here. So we have that the integral I is 25 over 2 times the natural log of 5 minus a half e squared times the number 1, because the natural log of e is the number 1. So minus a half e squared okay? And then we're going to take away this. So a quarter times 5 squared is 25 over 4, and taking away inside of the bracket a quarter times e squared, so e squared over 4. Okay, then we just need to clear it up. So the integral is equal to 25 over 2 times the natural log of 5 minus a half e squared minus 25 over 4. We now have a double negative, minus minus. That becomes plus e squared over 4, okay? And then one more round of simplifying. We end up with 25 over 2 times the natural log of 5. We have minus a half e squared plus a quarter e squared. That's minus a quarter e squared, so minus 1 over 4 e squared minus the number 25 over 4. You could factor out a quarter or something if you like. I don't really care too much about that. So that's how I would leave the answer, just this. So this would be the answer to the integral. Okay, guys. The second integral that we're going to do is the integral of x squared times e to the 3x. Now this question can be a bit tricky for some people because there's a bit of a subtlety to it. So if you ever have a situation where you have some function like e to the 3x multiplied by x to the power of n, where n is a natural number, that is going to require you to do integration by parts n times. So what I'm saying is because there is an x squared there, we have to do integration by parts twice in the same question, which sounds a bit crazy, but I'm going to show you exactly how to do it. It's not that bad at all, but it's just a bit of a longer question, so we'll kind of go through. So once again, guys, we need to determine what should be u and what should be dv dx. So again, I might encourage you to pause the video for a moment, think about what should be u and what should be dv dx. Okay, so u is going to be x squared, and dv dx is going to be e to the power of 3x. Again, think about the acronym LATE, logarithms, algebraic, trigonometric, exponential. The higher up that list we are, the more we want that to be u. We have an algebraic function and an exponential function. X squared is algebraic, e to the 3x is exponential. And exponential in LATE, L-A-T-E, the e is at the bottom, which means we want that to be dv dx the most, and x squared is algebraic, that's higher up the list, so that's why it's being called u, okay? We're then going to do the normal stuff, so we just need to find what du dx is, we need to find what v is. So du dx is 2x, just by differentiating that, and v, we need to use the chain rule to integrate e to the 3x. That would be a third e to the 3x. Or I guess I should say the reverse chain rule. But we just need to think the reason why we have a third there is because when you differentiate e to the 3x, a 3 comes down, and so a third e to the 3x differentiated, the 3 will pop down, 3 over 3 is the number 1, and we get back to where we were. That's kind of the logic. Okay, and then we just substitute that into our integral. So the integral of x squared e to the 3x is u times v, so u is x squared, v is a third e to the 3x, so this is x squared over 3 e to the 3x, okay, minus the product of these two, so minus 2x times a third e to the 3x, that's going to be 2x over 3 e to the 3x dx. Now, you might be able to see, oh, that's well and good. I guess we've simplified the integral to an extent. But the problem is, guys, is that the integral that we are left over with still needs integration by parts to solve, because we have an x times an e to the 3x. So this still needs integration by parts. So what we need to do is we need to use integration by parts to figure out what this is equal to. So I'm going to do I'm going to do it in orange here, or in yellow. I guess I'm a bit colorblind. We're going to use this yellow, and I'm going to do it up here. So we're going to do the integral of 2 over 3x e to the 3x dx. And we're going to do integration by parts on this, so we can figure out what this is and replace this with whatever it's equal to, if you're with me there. Okay, so u is going to be 2 over 3x. It doesn't matter which function you assign the 2/3. You could give the 2/3 to e to 3x, it doesn't matter. And dv dx will be, once again, e to the 3x. And we're just going to do this again. So du dx, what would du dx be? That's just going to be 2/3. And v is, again, 1/3 e to the 3x, okay? Cool. And then we're just going to use the formula. So we have that the integral of 2x over 3 e to the 3x dx, this integral is equal to u times v, so 2/3 x times 1/3 e to the 3x. That's going to be 2/9 times x e to the 3x. And we're going to take away the integral of 2/3 times 1/3 e to the 3x. That's going to be 2 over 9, if I have space here, e to the 3x dx. Just about have space. 2 over 9 e to the 3x dx, okay. And this is equal to 2 over 9 x e to the 3x minus, and guys, what's this going to be equal to? Again, we need to use the reverse chain rule. 1/3 is going to pop down, and we're going to have minus 2 over 27 there, times e to the 3x, just in that corner there, okay. And there is going to be a plus c, but I'll put the plus c at the end. Okay, so we now know that this is equal to this. So in the actual whole thing, the integral of x squared e to the 3x, that is equal to x squared over 3 e to the 3x minus this, which is equal to this. So minus 2 over 9 x e to the 3x minus 2 over 27 e to the 3x. And now I'm going to put the plus c on the end. And we're going to do one more round of simplifying. So we've got x squared over 3 e to the 3x minus 2/9 x e to the 3x minus, and minus, guys, that's a plus, so plus 2 over 27 e to the 3x plus c. Okay, I know that was pretty tough, wasn't it? Quite a lot of working out, but that's how you deal with a question that involves integration by parts inside a question that involves integration by parts. You just do what you would assume. It's just a bunch of algebra at the end of the day. It's just a bunch of working out. There is a simpler way to do this called the DI method, which I will do a video on in the future. It will save you countless years. Maybe that's a bit of an exaggeration, but it will save you a very long time. And actually, you could do an integral like x to the power of 10 times e to the 3x. And with this DI method, you could do it in about 5 minutes. Even though you technically need to do 10 integration by parts, you can do it in a few seconds, really. It's very cool. That's called the DI method. And again, maybe I'll put the link to that video in this video when I make it. Thank you guys so much for watching. I highly appreciate it. And I'll see you in the next